Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take Basic Thermodynamics Model 3 Lecture 5, that is heat engine and its efficiency. Already in the previous session, I have taken the working of the heat engine and how that works. Here we can see the heat engine receives the heat from the hot source or a higher temperature source, and part of that heat it will convert into a work, and remaining heat which is not possible to convert into work, that is rejected to a cold sink or a lower temperature sink. And here the heat input is taken as a QH, and heat out, that is a heat out means that is a rejecting heat is taken as the QL, and the work done we are going to take as a W. And here is the how the efficiency is taken, that I will take the explanation in the next slide. Here, heat engine efficiency. Here we'll consider heat is supplied at a QH amount from the hot reservoir at temperature TH or higher temperature reservoir, and that heat engine converting part of that heat into a work, and remaining heat it will be rejecting, that is the heat rejected as a QC, the heat rejected to a cold temperature reservoir, or we can say the cold reservoir at temperature TC. Then work done will be the difference between the heat supplied and the heat rejected, QH minus QC. Then generally we know that the efficiency will be the output to the input. The output is the work done required. Then the input is the heat supplied. Therefore, this can be taken as the QH minus QC by QH, and after simplifying we can write eta is equal to 1 minus QC by QH. And in terms of the temperature, if we substitute this QC and QH, we are going to get the maximum efficiency. Then eta max can be given as 1 minus TC by TH is the maximum efficiency. And how this efficiency is calculated, that once again we'll discuss, that is in general efficiency or performance is the desired output by required input. Therefore, thermal efficiency of a heat engine is net work output by total heat input. Then eta Th is the W net out by Q in. The net work output can be given as heat input minus of the heat output. Okay, the difference of that will be the work done. The Q in minus Q out by Q in, where W is the QH, that is a heat supplied from the hot reservoir minus of the heat rejected to the cold reservoir QC. Then it is also expressed like this: if the Q in get cancels the Q out by Q in, therefore eta Th can be written as 1 minus Q out by Q in, and that can be written as 1 minus Q out is the QC and QH is the Q in, 1 minus QC by Q in, or in terms of the temperature we can write TC by TH. This is the heat engine efficiency. This we are going to use for the calculation of the heat engine efficiency in the further sessions. In next session, I am going to take the coefficient of performance of heat pump and the refrigerator, and that is somewhat different from the heat engine efficiency. The heat pump and the refrigerator work in the reverse of the heat engine, and its efficiency called the in terms of the COP, that I am going to discuss in the further sessions. Thanks for watching. If you like, share, subscribe and comment.